Significant advancements have been in the performance and efficiency of battery chemistry and technology over the last 5 years. Despite this, we continue to face the same challenges. Today's batteries have a long charging time, short range, and exorbitant costs. Elon Musk, however, thinks that he's just made a breakthrough that will transform the EV industry and make it dominant. So join us as we take a look at the brand new LMFP battery and discuss how it has the potential to revolutionize the EV world. Before we get started, if you want to help our channel grow and keep bringing you even more exciting content, please give a thumbs up and hit that subscribe button. We'll really appreciate it. Now let's get right into it. Elon Musk, Tesla's CEO, first proposed the possibility of batteries with a manganese cathode at Tesla's Batteries Day event in 2020. Musk expressed concerns about the complexity involved in manufacturing batteries using graphene, a material that had garnered attention in the industry. The use of graphene increased the cost of production, which in turn resulted in expensive EVs. Musk stated that it is important to focus on the battery supply chain starting from the minerals used in their production to combat the costs of the EVs. He placed emphasis on the utilization of other alternative resources, such as manganese, as a viable option by investigating various chemical processes and materials for the creation of batteries. The goal of Tesla's work on its electric vehicles is to increase their efficacy in terms of efficiency, performance, and cost. The current generation of lithium-ion batteries used in electric automobiles frequently relies on cobalt, a metal that is blue-gray in color and contributes to the enhancement of the battery's power capacity while also contributing to the battery's safety. But cobalt is not without its problems. It comes at a high price, and the extraction is done in politically dangerous locations. Because there's an ongoing increase in the need for energy storage, there is a concerted effort to identify battery chemistries that minimize or do away with the requirement for cobalt. Researchers at the Argonne National Laboratory, which is part of the United States Department of Energy, are working on a technology that revolves around manganese, which is one of the metals with the greatest abundance on Earth. The project's goal is to create battery technologies that can be employed in electric vehicles and energy grids. In order to effectively manage variable energy supplies like wind and solar electricity, grid applications absolutely require the use of battery storage. The researchers anticipate that by utilizing chemistries based on manganese, they will be able to produce energy storage systems that are more environmentally friendly and economically effective for various businesses. And now, one of China's leading battery manufacturers, Gotion, believes it has developed a method that may produce cheaper and more powerful battery packs for electric vehicles. Gotion has recently introduced a lithium-iron manganese phosphate battery, which it refers to as LMFP for short. The company claims that one battery charge can run an EV for 1,000 kilometers, equivalent to 621 miles. As the interest in batteries based on manganese continues to increase, many companies are getting the ball rolling on investigating its potential as a viable alternative. The 621 miles range is a huge accomplishment that can potentially alleviate one of the primary concerns for every motorist. Battery technology developed by Gotion could contribute to the increased use of electric vehicles by easing worries about their limited range and the need to recharge them more regularly. Manganese has been added to the existing lithium iron phosphate chemistry, which has already achieved commercial success in China and is used by key electric car manufacturers like BYD and Tesla to cut costs for specific models. Incorporating manganese into the chemistry of LFP enables considerable gains in power and energy density. Breakthroughs in LFP technology have already played a vital role in promoting its wider adoption because of its lower cost and more compact form factor. In the past, the energy density of LFP batteries was capped at approximately 191 watt-hours per kilogram, considered the maximum allowable value. On the other hand, the new battery technology developed by Gotion has the potential to produce an impressive energy density of 240 watt-hours per kilogram. Because of this improvement in energy density, each battery cell can now store more energy, which reduces the overall weight and size of the battery pack. It allows manufacturers to develop battery packs that are lighter and more compact without affecting the driving range or performance of electric vehicles in any way. This development makes electric vehicles more efficient as a whole and offers greater design flexibility for electric vehicles, allowing for automobiles with improved aesthetics and increased functionality. Gotion, a business that is listed on the Shenzhen Stock Exchange and has the Volkswagen Group as its top stakeholder, has lofty goals for the LMFP battery it's developing. According to Li Chen, the business predicts that the LMFP battery will cost around 5% less than the standard lithium iron phosphate batteries. Because of this cost advantage, the LMFP battery is also significantly more economical than nickel-cobalt batteries, and it might potentially give a cost savings of up to 25% in this too. Because of this large price difference, the LMFP chemistry is an appealing choice for automobile manufacturers who are interested in lowering production costs while maintaining the same or higher level of performance. The LMFP batteries provide performance that is comparable to that of nickel-cobalt batteries, but at a far lower cost and with improved safety features. Chen is convinced that the Gotion LMFP battery technology will garner a great deal of interest from automobile manufacturers, and he forecasts that a significant number of businesses operating in the sector will adopt this. The technology of LFP is not brand new. These cells have not traditionally seen much use in electric vehicle applications because of various difficult technical issues. These problems include dissolving, poor energy density, high temperature, and low conductivity. However, Gotion asserts that its new battery overcame the challenges often connected with LFP batteries by integrating manganese into the chemical composition. Compared to regular LFP batteries, Gotion batteries have superior conductivity, a lower high-temperature threshold, and more solubility. Victoria Hugo, a research analyst in charge of battery development at the London-based consultancy RHO Motion, has also acknowledged the potential of Gotion manganese-enhanced cells. She believes that these cells will create real opportunities for LMFP batteries to compete with NCM chemistry in terms of energy density. She also mentioned that LMFP has the potential to capture 6% of the market by the year 2040, which would put it ahead of other emerging possibilities, such as sodium-ion batteries. According to Chen, Gotion anticipates that it will begin mass manufacturing its batteries as soon as the second quarter of next year. The batteries have previously demonstrated their ability to perform well in safety evaluations, demonstrating that they're up to the required safety criteria for use in commercial settings. Gotion claims that to manufacture LMFP batteries, it will first start with its facilities located in the province of Anhui in China. In addition to its operations in the home market, Gotion has been working hard to develop its position in international markets. The corporation has made substantial headway in its worldwide operations, which include intentions to develop a battery plant in the state of Michigan in the United States. Additionally, Gotion has taken action to raise capital and expand its global visibility by offering global depository receipts in Switzerland. This decision opened the doors for investors from other countries to participate in Gotion's expansion, and it also served as a statement that the company intends to broaden its presence on a global scale. Gotion has seen success as a consequence of the efforts that the company has put out, as it was recognized as the 8th largest battery manufacturer in the world in the previous year, according to the findings of the SAE research. This ranking brings to light Gotion's position as a prominent participant in the battery business worldwide, thus enhancing the company's prestige as well as its potential for future accomplishments. Chinese companies have made a number of notable advancements in battery technology in recent years, and one example is the Blade battery, which was first shown by BYD in the year 2020. The LFP chemistry is used in the Blade battery, but it has been redesigned to be more streamlined, and its energy density has been increased. This results in greater performance and overall efficiency. CATL is another significant player in the Chinese battery industry. They're currently working on the development of a condensed-state battery. This cutting-edge battery technology is still in the process of being developed, but it shows great promise for the realization of additional advances in the capabilities of energy storage. One of the benefits is the capacity for rapid recharging, which may be accomplished in slightly more than a quarter of an hour at the most. According to Mr. Chen, he stated that if you drink a cup of coffee at the charging station, the battery can charge from 10 to 80%. But what are your thoughts on this new battery? Let us know in the comments section. We appreciate your support and thank you for watching. Stay tuned for our next video.